Okay, I suck at relays, but this is fabulous. So, Engineering Better Medicines. I'm Erin Lavik from Chemical, Biochemical, and Environmental Engineering. Does this thing move forward?
It'll move forward. Okay,
you can tell I'm like, I'm ready to go. So, nature is actually our guide for engineering better medicines. Are you sure it's moving forward? I've got my whole talk basically done in my head. Excellent. So nature really is our model here. We're taking on trying to figure out better medicines. If you actually look at what the National Academy talks about for this, they talk about a whole host of different things. And I'm going to try to tie my research into it, which I will admit is a little bit on the indirect side of things. But we clearly need better medicines. We need better medicines for a host of diseases. The one that you'll see, in fact, they talk about personalized medicine, big data, and novel materials. They're really clearly interested in cancer, but we need this for a whole host of conditions, cancer included, but well beyond it. And MAR research is actually is focusing on traumatic brain injury as it applies to all of this. And this was not something we went into thinking today we're going to cure traumatic brain injury. It really came from being interested in trying to treat blast trauma more broadly. And what we found when we started looking at blast trauma and at the condition was that traumatic brain injury is a big component of this. You may have heard about veterans coming home who have been exposed to blast trauma who have a lot of anxiety. Turns out that's probably caused because they have damage to their amygdala. And what we're interested in is how can we get a targeted therapy there to treat that. And these are our targeted therapies that I didn't know would fly, but apparently they do, which is extra awesome because in fact they do. We can administer this systemically, they get injected in the bloodstream, and they interact with platelets. So we're leveraging biology to go after the injury because they can stop the bleeding, and we can use platelets to piggyback them into the brain and hold them there and actually potentially deliver them across the blood-brain barrier, which is one of the huge barriers to actually doing any kind of therapy in the brain. Big problems with this. It's not surprising. It's complicated. We don't even necessarily understand the injuries particularly well, and we're trying to develop a therapy for it at the same time. But the benefit of that is if we develop something that works, it gives us new insight into the problem itself, which is where the feedback system I really think really works kind of brilliantly. To do that, though, you're going to need a massive interdisciplinary team, and we're really lucky to have that. And this is a great area for taking on big problems because there's so many people interested in medicine in this area. Just to give you a sense of the team, we have a biomechanics person, a platelet biologist, an endothelial cell biologist. We have a bunch of neuroscientists, a bunch of trauma surgeons, and in fact, my wonderful team and collaborators here at UMBC. And all of us have to work together to make this happen. And I'm out.